Bismillahirrahmanirrahim. Now we are going to start the microbiology. Before I go to the detail of the lecture, so first of all I want to tell you that this lecture is not limited to the introduction part, because we have to cover some important aspect related the different microbes as well as the normal flora we have to cover. But because it's first lecture, that's why I mentioned it's an introduction to microbiology. Although you are familiar with the term, the microbes, they are related to those organisms which are only observed by the microscope. We cannot see by this eye. This term, I think, first time in the late 19th century, this term was used, microbial. Then, as the transition in the different era of our world, so same thing happened to the transition in the microbial. Microbiology is actually we consider in the discussion of pathology, but if we take a microbiology a separate subject, it's a very well. We are not going to detail of all the aspects. We are limited to the medical microbiology, because we see there is a food microbiology, there is a biotechnology, agriculture microbiology. So there are so many branches, because the fields of the different major aspects of this field are so many, but we are limited to the medical microbiology, means the applied part of microbiology which is associated with the different diseases. Okay, so we have to discuss because most of disease, which more than 50% of disease you find in the society, they are coming from the microbes. So, but these are limited number. There are billions of, you can say, are the microbes which are present in the body. They are beneficial. Okay, so just take a start. The medical microbiology first, as you know. So these are those classes of you can say those organisms which can be only observed by the microscope. Okay, so it's a study of the causative agents of infectious diseases. So that's why sometimes we also study in microbiology, or we can say it's we are studying the infectious agents. So causative agents of infectious disease of human and their reaction to such infection. So we are actually discussing the medical microbiology. So these agents are not limited to any specific thing. They are distributed everywhere in the air. You can say soil, water, animals, human body, fruit, the world. So if you compare the number of the microbes in the feces, they are more than the total population of human beings. So they are, but thanks to God, they are the macroscopic. If we can visualize by our eyes, it's too difficult. It's irritating discussing with, for example, if they are sitting on my hand throughout the day, I'm washing my hand again and again, and they are still here. So thanks to God, it's a microbial. If they were visualized by our eye, life becomes so difficult. Okay, so in the other words, it deals with the etiology, meaning the cause of disease, and the pathogenesis, how the disease is going to be, the mechanism of disease, and the laboratory diagnosis. So specific treatment, control of infection. So all these things we are actually interested in the medical microbiology. Okay. So why is it important? Because more than 50% of diseases of human beings are coming from these microbes, and their wide prevalence and their transmission between people to animal, people to people. So that's why this is important. So and you're challenging treatment, because day by day there is as we are evaluating, the microbes are also evaluating. So the drug which actually we use against the microbes, we call them the antibiotics. So they are day by day they become resistant to these. So that's why we need to study them. I think although it's part of the pathology, but it's also important especially the antibiotic study, which is part of our pharmacology. So if you don't understand the structure of these microbes, so just consider these like an enemy. When you want to kill some enemy, you need to maximum information regarding their structure, their lifestyle, all these things. So we can attack them. So because we want to prevent people from their infections or the problems they are creating in our world. Okay. So for this purpose, we go for the immunology. Immunology is simply the study of mechanism of body protection. Okay, so for the study of the immunology, first we need to study the microbiology. So five major groups we need to study in the microbes. So number one is the viruses. The second is the bacteria, and the third is the fungi, or you can say yeast and molds. And the number fourth is the protozoa, which you commonly call the protists. Okay, and the number fifth, which you call them worms, are the helminths. So helminths. So all of these five are the again are not the one subject, but we are limited to the medical their perspective. So viruses, study of the viruses we call them the virology, and the study of the bacteria we consider them the bacteriology, and the study of the fungi we name them the mycology. Okay, and the protists, so we name them the protozoology, and the helminths, so helminthology. But collectively, the study of the protozoa and helminths are the, you can say, protozoology and helminthology. We consider them the parasitology because they are parasites, live in our body, but they always cause a harm, or you can say problem in our body. So we name them the parasitology. If you look at these lower three, the fungi, protozoa, and helminths, so they are the eukaryotes, while your bacteria is the prokaryotes, and the viruses, they are not considered as a cellular, so they are non-cellular, you can say, because they are in between something. So when they come into our body, they use the host organelles for their development, for their reproduction. So they are non-cellular, so not considering that actually true organism, or you can say the species. Okay, so our for the name, because as we have to discuss all of them, so first we need to know what is the nomenclature. So they use a binomial nomenclature. Binomial means they have two names. Number one is the genus name, and which is always start with a capital letter, and the second is the species name that start with a small letter. Let's look at a Clostridium. Clostridium shows the your genus name, while the tetany show the is the species name. And Escherichia coli. So Escherichia show the genus name, coli represent the species name. And Candida albicans, which is fungi. So it is a genus name, it's a alveolate. The other is the species name. So how we name them commonly, if when we want to in the printing, we commonly in the italic manner, like that. But in the script, when we in the especially in the exam, when we underline them because the italic manner is not properly can not be written by a student in the script manner. So the underline is the better option. So and sometimes we simply in the shorter form, but E. coli, but we can't read it like E. coli because it's wrong. It's just for the written purpose. So we for the reading we always read the Escherichia coli. Okay, so but because viruses they are different things, so we they don't follow this system. So you can see, for example, polio virus and the measles. So measles viruses are the simplex viruses. So they don't follow this nomenclature. Okay. No, because as I mentioned, so first we need to compare the prokaryotes and the eukaryotes. Then we go for the comparison of all these five major groups: the viruses, bacteria, fungi, protozoa, and so first we need to compare the prokaryotes and the eukaryotes. So if you look at the prokaryote, on the outer aspect you can see a cell wall. Okay, so and here is single circular. You can say single circular chromosome is present here. So like this, and the extra chromosome is present here. But you can't see if you compare here. In this here is a nucleus where you can where chromosome is present, but it is encircled by the nuclear membrane, or you can say nucleolus is present, and other the membranous bound organisms like mitochondria is present, the rough endoplasmic reticulum, Golgi apparatus. So such kind of things you cannot observe in the prokaryote. So the membrane bound organelles are absent. So just comparison. So number one, they have nucleus, but In this case, they have no nucleus, so we consider nucleate. Because nucleate means epithelioid mean what? Nucleate means like nucleus, not a nucleus. We consider nucleus when there is a proper nuclear membrane. If the nuclear this membrane is absent, so mean then we consider the nuclei, and here is a single circular the chromosome. Here you can see when you see a eukaryote, there are pair of the chromosome and they are covered by the nuclear membrane. Okay, so this is difference between the nucleus and the nuclei. So other thing, membrane bound organelles, like as mentioned, the mitochondria and the lysosome, so they are present in the eukaryotes, but you can't see in the prokaryotes. The other thing, multiple linear chromosomes inside the nucleus will be present in the nucleus here, but in the prokaryotes, there is single circular free inside the cell, which is not covered by the your membrane. Other thing, they because their size is much larger, they are lengthy, so we need the for their compression, we need the histone protein which is present in the eukaryote. It's also present in the prokaryote. So that's why these features actually important for the that's why because of absence of histone, absence of the nuclear membrane, only single circular chromosome. So that's why we named them the nucleate. Other thing, ribosome. You know better the ribosome of the eukaryote. There are 80s and 50s of larger and 30s. Sorry, it's wrong. It's not 50. It's a 60 plus 40s. Okay. Well, in the case of the prokaryote, there is a 50s and the 30s, but the totally we consider them as S is actually simply the segmentation or coefficient or segment which is, we use for the size comparison. And this is modern form of life, where the prokaryotes is the old form of life. So, example, protozoa, fungi, animal, plant. So, they all are eukaryotes, but the important one is the bacteria, which is the prokaryote, big example. Okay, so if you look at the some points regarding viruses, so there some are less infective agents, and they have no cellular structure, they are acellular and oblique intercept, mean they for their life they need all the cell of the host, like the human being. So when they live in the host, they are alive, otherwise they are dead. Okay, so mean they need biochemical machinery for their reproduction and the survival. Okay. So other term which is used is the prions. So prions is actually it's not a virus. It is actually infectious protein which have no DNA, no RNA, so and only a protein. So they are resistant to inactivation, heat, ultraviolet because their structure is different from the viruses. But for the for sterilization, we use the hypochlorite and sodium NaOH, or you can say sodium hydroxide, and the autoclaving. So these for the sterilization purpose we use them. And as I mentioned, because they have no DNA, no RNA, so we sometimes we call them the slow viruses, but they are more dangerous because no treatment is available for the prion diseases. And if you look at the normal structure, so the normal structure they have alpha helix configuration, but for the pathogenesis they change their shape into beta pleated shape like that. Okay, so which you normally study in the hemoglobin structure. So this is just for information, but not to memorize. Just you have to idea what is prion, and the virion, which is important for the plant, not for us. So they are different. They have no protein, but they have the RNA segments. Okay, they are opposite with the prion, you can say. So important in the disease in the plants. So these are actually terms associated with the viruses. So now we are actually this major table which I am going to do. It's very important because throughout your study of microbiology, you must need to know the important aspect regarding the viruses, bacteria, and the fungus and the parasite. Number one, their cell. If you know better, viruses they are non-cellular, while other they all have the cells, their cellular structure. Second thing, the diameter. As you go from viruses, bacteria to fungus to parasite, so their size is continuously increasing. So we consider in the micrometer. So 0.02 to 0.2. So this is for the viruses, and for the bacterium this is 1.5, 1 micrometer to 5, and for the 3 to 10 for the yeast, or you can say fungus. For the parasites it's 15 to 25. Okay, so trophozoites. And if you compare the second thing, DNA, RNA, in the viruses, there will be either a DNA or RNA, while in all other cases they have both DNA as well as the RNA. Okay, so this is important for the viruses differentiation. Another thing, nuclear state. You know better. Viruses, they have no nucleus because they are non-cellular, while the bacterium, they are prokaryotic type, which you consider the nuclei. While the fungus and parasite, they have the proper eukaryotic type nucleus. Okay, so other thing, ribosome, as you mentioned, so viruses, because they are non-cellular, so it should be absent, while in the bacterium, it is 70S, which has 30 and 50S, the subunit, and 80S in the case of the fungus and the parasite. Okay, because they are eukaryotic type. So other thing, this actually ribosome information is important because this is one of the target for the antibiotics regarding the your bacterium, because it differs from our ribosome. Okay, 70S. So when we make an antibiotic which can attack, like the drug which can attack the 70S, because it's easier, they don't affect our body. Organelles, because they always use the virus always use the host organelles, while the bacteria, they have no membrane bounds because they are prokaryotes, while the fungus and parasite, they have proper membrane bounds because they are eukaryotic. If you look at the cell wall, parasite there is no cell wall, but the bacterium, as you mentioned, they have the cell wall which is peptidoglycan, while in the fungus it's a chitin type, because it's one of the differentiation point for the bacterium and the fungus. So this chitin is important because of this chitin, they cause the calcification in our body. So when someone faces a fungus disease, so pathology, so calcification is one of the important signs for the fungus. So because they are indigestible, so they lead to calcified lesion. Okay, cell membrane. Cell membrane, so they have enveloped naked, but it's not a functional one. So for the viruses, while in case of the bacteria, so they have the membrane, but it is there is no sterol. Okay, so only one exception, that is the mycoplasma, which has the sterol. Why it have the sterol? Because in the mycoplasma there is no cell wall. For the strengthening, the alternative option is the sterol. It is one of important feature in the study of the bacteria. Okay, well, if you look at the other in the fungus, there is ergosterol, while in case of parasite, so have cholesterol. So this is one of another differentiation point through which we can, if you look at when you observe them, if ergosterol is the identification point for the fungus, and it's also attack for antifungal antifungal drugs. So they attack the ergosterol because it's important for the fungus, and cholesterol is important in the parasites. Okay, so if you look at motility, viruses, they are non-motile, while the bacteria, some, because which have dependent upon the flagella. If the flagella is present, so they are motile. So, but the fungus, they are non-motile, while the parasite, they are most of the forms, you can say, because they are motile mobilely. Replication, if you look at the replication, so this is complex because this is dependent upon the host. They may use the bacteria, they may use the host as a human being, any living human being or something else. Okay, well, if you look at the replication, there is beneficiation and asexual. Have you ever seen the word it's a male bacteria or a female? No, there is male and female because they are asexual, so single sex. So, but their division is beneficiation. What is beneficiation? If you look at it here, for example, here is one cell present here. So, mean after they divide into two like that. So they divide into two, and again they form another cell two. So again this will divide. They form the other, you can say, fourth cell. So It's actually exponential growth. You can say here is one, here is 2, here is 4, then 8, then 16. So they divide like that because band division where we use the 2n. For example, if the here is 2 power 0. Okay, well here you can say 2 is 1. Here is 2 superior. Here is 2 power 3. So this process continues. So that's why we name the band division, and it's always asexual. Well, if you compare with the fungus where they form the budding, for example, there is a cell of fungus, so they form a bud-like structure. So they bud separate and form another which will grow into the proper the fungus. So this is important for the budding and the mitosis process for the fungus. So and parasite follow this. If you look at the nucleic acid replication, so because viruses totally depend upon the host, while their bacterium continuously follow the this band division. Okay, so they are continuously dividing while they are follow the G and S phase. Are you familiar with the G and S phase? Although this is all part of the biochemistry where you see the G1 phase, then they come into the S phase, then I think the G2 phase. After the G2 comes the M phase. So, and this cycle continue. Another some resting phase is also present where you see the G0 phase, and again come back to the. So this cycle is important for the eukaryotic. Okay, so they follow the G and S phase fungus as well as your parasite. While these they are showing the band division. Okay. So if you look at the mRNA, so their mRNA is polycistronic. What does mean polycistronic? Mean one gene. Mean polycistronic. One gene is for multiple. The protein is important. One mRNA can is enough for the synthesis of multiple protein. While in the mono mean you have single gene for one protein. So this is major difference in the polycistronic and the monocistronic. So the fungus are monocistronic and the parasite monocistronic, while the bacterium they some are the mono, some are the poly. Okay. Other thing, if you look at the genetics, so they have exons only. What is exon and while intron? As you say, it's a non-coding part. Actually, you can say the intron. For example, if you draw it here. Okay. So, for example, here is the this gene is present here. So in this here you will find some non-coding part like that. So mRNA is present here. So where you see the this non-coding part is actually considered the intron. So when we go for the utilization of this strand, we go for the splicing, mean we remove that, and again we come only exons. Okay. So these are actually in the genetics of the bacterium, they have only exons, while the fungus they have both exons and introns because they are the eukaryotics. Okay, I think this table is very important because throughout the when we study the bacteriology or the mycology or the parasitology or the virology, so always you need to recall these points regarding the each of the class. Now they come to the next stage, that is the relationship between the organisms and how they are related with the. So normally symbiosis, when two different organisms are living together, we consider the symbiosis. Okay, and if there was the three way, one is the mutualism, other is parasitism, the third way is the commensalism. So mutualism, when both are benefited, so we consider such relation is mutualism, parasitism. When one is benefited while the other is harmed. The host is always harmed, and the parasite which is benefited is the parasite. Okay, so commensalism, where one is benefited but other is not affected, so they are relating but they are not affecting the body. So these are commensalism. So these are actually relationships between these organisms and our body. So now very important aspect, that is the normal flow. You may have heard of this is actually, especially the bacteria, mostly bacteria and fungi, they are inhibited in our throat, in our skin, especially mucosa and skin, which is for example in the mouth, in the oropharynx, or you can say colon, where the billions of the bacteria are sitting there. So they are resident here. So these are considered normal flow because they are sitting here, but they cause no effect. You can say they are causing no pathogenesis. Okay, so they are present especially in the skin and the mucosa of human body, but they are different in number because if you compare these normal flora, which is sitting in our mouth, and compare with the colon, there is different in types, but then both are considered normal flora, but number and types is always different. So they are present in normal flora. So under normal condition, in a healthy human being, they are harmless. They cause no effect. But so we can say they are beneficial. For example, the bacteria which is sitting in our colon, or you can say the large intestine, they are producing vitamin K. So this is important for our body. But if someone is deficient, these normal flora mean the vitamin K is going to down, which is important for the coagulation mechanisms. Okay, so and they provide the nutrient, for example, vitamin K, vitamin D. So these are useful, and the antibiotics which is we use against the microbe. So they are also coming from the other antibiotics. The antibacterial compounds are also coming from the these non-flora. You can say they can be used early. And the host defense by competing with the invader, because for example, if the 50 chairs are in a classroom and the 50 students are already present, so there is no possibility the outcomer can sit in that class. If the 50 chairs but the 40 student is present, means 10 chairs are present empty. So that 10 chairs can be used for the outcomer. So same thing is happening here, but if the normal flora is enough in our body, there is less possibility for the any other the invader, or you can say any pathogenic bacteria come and affect our body. So and maintaining conditions, so they also decrease the for example pH in the vagina where they maintain the pH. Okay, so this is a lot of beneficial for the normal flora, but they can cause the infection two reasons: when they are misplaced, or when they are when someone is immunocompromised, means they are facing with a disease condition. So misplaced, for example, fecal flora, which there is no problem in the colon, but if they come to the urinary tract or the abdominal cavity, so or your skin flora, which is coming to the catheter, so these causing the problem. Mean important thing, their location should be fixed and their number should be fixed, and we should be healthy. For example, immunocompromised, my hand is normal here. If I injured, so these normal flora which are sitting on my skin, they cause a problem because I'm now immunity compromised. So if the person is immunocompromised, normal flora may not grow, and same thing is happening in your oral thrush. So they are normally there the normal flora, but because of some immunity problem, so we go for the oral thrush. Okay, misplaced and the secondary immunity compromise. So if the so we consider then the opportunistic parasite, because they harm the host when the host become immunocompromised. So such kind of parasite you consider in the opportunity, means they are waiting for the immunity compromised condition where they can attack our body. Okay. So the normal flora, there some are the resident which we have to mainly discuss, but there some other transient, mean they're come for shorter period because some you can say the bacteria are coming on my skin, but because of the dryness and the pH condition, so they don't favor them, so they get rid of our skin, get rid of those microflora, so they are transient, considered them the transient microflora, only temporary found in the body section. Okay, so another because nature always help, the natural process always helpful. And infants, for example, which is delivered by the cesarean section or C-section, so they have unstable flora for the longer period, because for the normal growth of the flora for infants, it's necessary they have to in contact with the rich dose of the mother bacteria, which is only possible when they cross the birth canal. If they are coming from the C-section, so it's possibility, so their immune system will be not well developed as compared to the other which is coming from the birth canal. Because of it is important they have to face those are the mother bacteria which is present in the birth canal. Okay, so C-section babies suffer with this problem because they have unstable flora, which is important for the vitamin K and other beneficial point vitamin B. Okay, and the other pathogen competition. So, but you must need to remember they are always absent in the blood. If you see the flora are coming in the blood, mean there is an infection. It's a sign for you can say are coming in your internal organ like spleen or liver, pancreas, CSF. So if they are coming right here, mean there is a problem. So it's only possible when there is a infection. Normally these organs are the sterile. Okay, so two terms which most of the students confuse. One is the bacteremia and other is the septicemia. Bacteremia means your bacteria are present in the blood, but they without any sign and symptom. But septicemia means they are present and multiplying there and causing some problems. So septicemia is the bacteremia simply presence but without any clinical signs. While the septicemia, the multiplication of bacteria and with the clinical symptoms. Okay, so here is a list of the normal flora you must need to know because these are again and again when we discuss they are coming in front. The definition this is tabular form you can say. They are present in the skin, they are present in the nose, in the oropharynx, in the gingival crevices and the colon, in the intestine you can say, and the vagina. So these 4, 5, 6 locations are very important. So I am showing two lists. One is the most important, so you must need to know. Others are also present, but they are less in number. So in the skin, the Staphylococcus aureus, as I mentioned, the Staphylococcus is so for the genus name and epidermis, dermis related to skin. So this is very important, but it is important for the skin, not for the other location. Okay, so if it's go to the it's may cause the effect if it go into the blood, it can lead to the artificial heart valve or the prosthetic joints, especially. So they can cause problem. Okay, because this is only important for the skin. If we enter into blood, so it may attack those organs which are artificially replaced. For example, your heart valve or you can say the prosthetic joints. So these can be affected by this Staphylococcus epidermis. If you look at the nose, Staphylococcus aureus, it's one of the most common causes of your food poisoning. For example, if you see your cook, because the location is nose, if you see your cook is touching his nose again and again, and also he putting his finger into nose, but he is continue cooking your food, and after that he come and you take that food. Eventually, what will happen? Food poisoning. One of the most common cause, because this is normal location is nose, not the stomach. You are taking that the Staphylococcus aureus into your stomach, or you can say the intestinal system or the GAT tract. So that is not a normal location. So this is one of the most common cause of your food poisoning. Okay, aureus means simply actually you may be familiar with this term. Aureus is golden. So because of when we grow them, they show a golden appearance. Okay, the other Viridon streptococci. So they are actually a group of the streptococci which we can say Viridon. So where you can say Streptococcus mutans is important. So they cause it dental plaque. They go into dental plaque and cause a caries. So these which you commonly call there is a worm sitting on my teeth. So these are actually these things. These are Viridon families. Okay, so this is one of the most common because they are normal location is oropharynx, not your dental. Okay, and various anaerobes which are sitting in your gingival crevices because it's the anaerobic condition which is helpful for the different anaerobes like bacteroids and the Fusobacterium, Streptococci, bacterium. So they are sitting right here. Okay, but if they go somewhere else, they cause a problem. You are in the colon, that is a bacterium pregalis, which is 99% of your GAT, which is forming the vitamin K. They forming the vitamin K. Okay, which is important for our body. Okay, and the other is the HRT coli. They are also sitting in the colon. So these are most important one. And if they if they come if the, your you can say the colon is perforated at any point, they lead to peritoneum inflammation. Why? Because this is not a normal location for the peritoneum. So they should be limited to the colon. Within again you see lactobacillus, which is important for the lactic acid. As they produce the lactic acid, so they suppress the other pathogens. So other pathogens are limited because of this lactobacillus. And the group B streptococci, various streptococci, so they are also present in the vagina. So these are most important, but some other are also present, like your Staphylococcus aureus is not limited to the nose; they are also made present over your skin. Cornybacterium, or you can say diphtheria, and the yeast, which is fungi and different anaerobe, versicolor. So these are present over the skin, but the most important is the epidermis for the skin. And this epidermis is also present in your nose, and the cornybacterium, various streptococcus, but they are low virulent as compared to the this list which I am shown here. Okay, so and your in the oropharynx, the other list, non-pathogenic Neisseria species are non-typable, the Haemophilus influenza. So Candida albicans, which is a fungi. So this is important. So because if they enter into bloodstream, they cause the disseminated infection like endocarditis. Endocard means the inflammation of your endocardium, especially the heart one. Okay, and the candidiasis, which is a problem if they enter into the bloodstream. Okay, so and if their growth, because as I mentioned, their number should be fixed. If they overgrowth, they cause the oral thrush, and if they go to the esophagus, where they cause the esophagitis. Okay, and if you look at the other list of the colon, the normal flora, for example, bifidobacterium here is present. So this is especially breastfeeding, feeding infants. They are important for this. Okay, but also present in adults, but the other list is present here. So this Candida albicans is not limited to your the oropharynx, so they are also present in your vagina. If they overgrow there, they cause the vulvovaginitis or the diaper rashes. They are also coming from this Candida albicans. So this is a complete list of almost you can say not a complete list, but somehow very important, which is mostly tested over the years. Step one example. Okay, if you review them, we have location is skin, nose, oropharynx, gingival crisis, colon and the vagina. So important for the skin is the Staphylococcus epidermis, and the nose is the Staphylococcus aureus, which is most common cause of your food poisoning. And for the oropharynx, this is very dark family, which is Streptococci, so which cause the dental caries and gingival crisis. So they are anaerobes. Well, in the colon, which is bacteria, Fragilis, which is important because they produce the vitamin K, 99% K bacteria, and the vagina, lactobacillus, which produce the lactic acid and suppress the other pathogens. So if your Candida albicans overgrow, they cause the vulvovaginitis or the diaper. So these are all normal flora, but opportunistic one. So, and the other example, the Candida albicans, if they enter, which are present in oropharynx, if they enter in bloodstream, they cause the endocarditis, your inflammation of endocardium of your heart, especially heart valve. Candidiasis they can cause, and the overgrowth lead to oral thrush and esophagitis, but in the vagina they cause the vulvovaginitis or your diaper rashes, which you commonly see over the babies. So their cause of this is major cause of those diaper rashes. Okay, so and your subacute endocarditis is also important for the oropharynx. Subacute means because they are low virulent. So if you compare the acute and the subacute, acute means they are rapid onset. They are, you can say, they cause more illness as compared to subacute. Subacute is slowly growing and less virulent. Okay. So I think this session is over there. So we look at the bacteria structure. I mean, we are going to start the bacteriology in the next segment. So thank you very much. Allah Hafiz.